how do we help computers understand the nuances, the complexities, the contradictions of human language, and how to all do that in the context of Ruby, which is, of course, one of my most favorite computer languages. So before we get started, just a little bit to do together in our time. We're first going to have to address the most basic question, which is, this entire conversation matter? Why should we care about training computers to understand human language? And once we've talked about that a little bit, we're going to then have a high-level overview of what is sentiment analysis, what is natural language processing, what are some of the rules around the that computers construct the constructs which enable them to understand human language. Then we're going to build something together that takes advantage of natural language processing to and answer an area in life that I know is something I think about a lot. We're going to build it, and then we're going to analyze and what that data can teach us about the state of natural language processing and sentiment analysis today. So before we get started with the bulk of the conversation around the actual technology, let's take a bit of the question of why does this matter? And I think you have to answer that question by positing the following idea that language is not only a passive vehicle to convey point A from person X to person Y, meaning language is not just about the information, but language itself shapes the ways in which we think and shapes the ways in the ways in which we say things and what we don't say. So I'll give you a quick two examples from the world of linguistics. Let's take this that might happen with your best friend, the panda, around the water cooler pre-coronavirus. So you're standing around the water cooler, you're properly socially distanced there, and you say to your panda friend, last night I had one and it was delicious. That sentence in English, a simple, straightforward English sentence, conveys a couple things. It tells the person or that you had dinner the previous evening, you had it with another human being, and the it there can only be the dinner, right? The it is the only thing it can refer to dinner. The it was delicious. That sentence to native speakers sounds quite fine. Think about it within the lens of other languages. Vast majority of human spoken languages, there's other grammatical constructs and grammatical limits that actually force you to say more than you might have wanted to say in that moment. So I'll give you one example, and this that we have in this presentation, not in English, but it's a show to make clear what I'm talking about. So this example would be from the language of Hebrew, but it could also be from Arabic or German or Italian or French or a myriad of other languages. That's the exact same sentence Hebrew, but the difference is in Hebrew, every single definite article, every properly named entity has a gender assignment. So a table is either a masculine or feminine word, a pencil is a masculine or feminine word, and a dinner is a masculine or feminine word. So in that case, dinner cannot be an it. The word it as a construct to describe something in a third person doesn't actually exist in the language. It is either a he or a she. So therefore dinner, the word dinner is feminine, so she was delicious. Just one difference in Hebrew. And the second would be that every word has a masculine or feminine definition. There is no construct called someone, male someone, or someone, a masculine someone, or a feminine someone. So in that case, you have to actually disclose to the panda friend identity of the person you had dinner with. So I had dinner with a male someone or a female someone. So language is, whether it's English or Hebrew or Arabic or French, actually contour what we are going to say and what we have to say and what we can hide and what we ought not to hide, just based on the rules of the language itself. One more example, which is egocentricity or geocentricity. So if I am a speaker of a language, I will refer to directions, let's say down the street to the coffee shop, as you exit the door and you make a left, make another right, go down the block left. And that's where your coffee shop is. But if I am a speaker of a geocentric language, the way I would describe those directions would be radically different. I would say something like, you go out the door, you make a west, you turn west, go down the street south, and then the coffee shop is on the northeast corner. In fact, a geocentric speaker, a native geocentric speaker, at all times understands where they are in the sense of the cardinal directions of north, south, east, and west. They know where they physically are at all times in relationship to those cardinal directions. And a great illustration of that is if I take my index finger and point to me or point towards me as an egocentric speaker. Usually, in almost all languages, I'm participants conversation to look at me. Look at me, I'm pointing to myself. But if I do that as a geocentric speaker, what I'm actually saying is look at what is behind me. Look at the cardinal direction behind me, not at me. So whether you're an egocentric or geocentric speaker actually frames a lot of how you come to understand your place in the world. And this is all to say that when a language comes into existence, or when a language leaves within the world of spoken languages, when it starts dying, a language goes extinct, unfortunately, a way of understanding the world also leaves. A way of understanding the world also is either birthed or leaves, depending on whether the language is created, the language has left us. That language actually frames the way it is a constructor of the very conduits for the ways in which we think about the world around us. And understanding those nuances of language actually helps to understand human society and the world in which we live. So understanding language is not just a technical problem to help us address technical issues. It actually is a pivotal, foundational question of helping us grow our comprehension and understanding and awareness of the societies in which we live and the world in which we live. It's a big deal. And algorithms, natural language processing, and sentiment analysis can actually assist us in getting to that place and understanding the world we live in. So having that as sort of like, why does this matter? Let's take a moment to discuss what are these things exactly. So these things, natural language understanding and sentiment analysis, are attempting to answer this prophetic quote from none other than Alan Turing, who authored in 1950, when he said by 1999, we would no longer see the juxtaposition of the word thinking and the word machine in contradiction to each other. Meaning that if you thought of the word machine and you thought of the word to think, or the verb to think, you would see them in consonance, not in dissonance, that they would go hand in hand. And the question we have to ask ourselves is, have we reached that in 2020 where computers and thinking actually in complete synchronicity, complete in sync with Alan Turing, who, the Turing test is named after, with the question of whether we can assess something as thinking or not with an evaluation. He thought that by 1999, we would have reached that stage. So if you think one way to understand whether something can think is by if it can understand the contradictions of human language, which is one of the hardest things to understand, it becomes a metric of assessment of whether machines are thinking. Can machines understand our thinking? Can they understand the way we speak to each other? If they can understand the way we speak to each other with all of its ambiguities, all of its complexities, all of the double negatives, all the sarcasm, then perhaps we can say that computers are thinking. That's the question that we have for us as we continue in this conversation. So taking that sentence with around the water cooler and the panda, last night I had dinner with someone and it was delicious. When you run that through a natural language analyzer, what you get back is a whole set of objects. You get back objects like semantic roles and the keywords and emotional scoring and categories. And just as this is actually a real analysis of that sentence put through a natural language. And you see that it is able within the semantic roles category to understand the subject, to understand the object, to understand that the action was have and it was put in the past tense, and understand that the subject there is me, and that the key word there was last night with a 99% relevance score, followed by dinner with a 67% relevance score, and scoring is overwhelmingly positive, at 85% scoring of joy. So, and we see that even more so, that it even understands that we're talking about food and drink. That's pretty cool. Moment here to understand how far we've had to come to get to the point where, yes, that's a relatively simple sentence, get to the point where we can feed that into an analyzer and get back that kind of data. So how do we get that data? Well, we get that data through a lot of different things. We have to teach our algorithms all the rules of human speech, things like formal grammar, inflectional endings, parts of speech tagging, the root form of words. And these things are all important because take inflectional endings. It's very different between a police helps dog bite victim or police helps dog bite victim. The way I inflect that sentence, one thing can mean something radically different from the other thing. So we have to teach our algorithms to understand not only the formal grammar, and we can, there's probably data sets that have the formal grammar major human languages on Earth, but to actually also teach it the way in which we intend inflection to be there. So in addition to that, we have other things like types of named entity, who is speaking about whom, what to what, the meaning of word meaning. So a lot of languages, one word can mean many different things, and its meaning is dependent on its context. So an algorithm has to understand the context of those, which is super complicated. So all those things help us, and there's a lot more, by the way, but all those things help us try and understand human language, try and teach computers how to understand human language. And on top of that, we have to understand the emotion of what we're reading to read. So if I feed the computer to read, if I insert some data from a book, I may, or from an article or from a blog post, I may not only want to understand what was the subject and the object and who to whom and the name entities, relationships, and inflectional endings. I may also want to understand what is the polarity of that sentence. And polarity is one of the chief principles of understanding sentiment. Polarity, as it sounds, is the search for the extremes. So polarity, as a rule, is one of the principles in understanding the sentiment and the emotional content of any given human language set of words. So let me give you 3 examples of polarity scoring, going from easy to most difficult, and these come from Wikipedia. So the first one would be, I dislike broken cars. I dislike broken cars is a relatively simply constructed English sentence, and the polarity there is probably around dislike, disappointment, frustration, anger. I don't like cars that don't work. Pretty easy, not such a complicated sentence. We move on to something a little more complex. The next sentence, I'd really truly love going out in this weather. Well, I know we have people here from all around the world, and their weather in different places can be a whole spectrum right now in this time of year in May. Weather can be really cold, really hot, somewhere in between. Well, I really love going out in weather. Depending on how one inflects it, it could either be, wow, it's so beautiful outside, let's take a nice socially distant walk on the beach. Or it could be, I really truly love going out in this weather. Yeah, right. It's horrid out. So the emotionality, the polarity of that sentence is utterly dependent on its context and on its inflection. So that's a bit more challenging to train a computer to understand the polarity in that sentence. And let me give you one last one to make this point crystal clear. The last one here is even more challenging. So the next example. Let's get it there. There we go. I love my mobile, but would not recommend any of my colleagues. Well, that's a complicated sentence. I love my cell phone, but would not tell my friends and colleagues to purchase it at all. Well, do I like the cell phone, or do I not like the cell phone? If I like it, why wouldn't I recommend it? And if I wouldn't recommend it, why do I like it? That sentence is rife with contradictions. And that sentence is nearly impossible to understand the polarity of because of that contradiction, because it's either something really friendly or it's really equivocatory, and you don't know where to place it. And the fact that we have a really hard time understanding that sentence is actually a really big challenge point for this entire field, because it may come as a shock to some of you. Humans speak with contradiction. We are full of contradiction. We don't always make sense in all the ways we intend to, in the way we speak, in the way we conduct ourselves. We are contradictory animals. So to understand human language, one has to understand that contradiction to fully get to that place. Now that we have a bit of understanding around why does this matter, and we have some high-level balcony perspective of what are the rules, the come into play to understand natural language analysis and sentiment analysis, let's talk for a second about something we can build with it that could shed some insight on the world we live in, because we said that part of what's so great about this, at least for me, is that it lets us gain greater insight into human society. So if you're like me, sometimes, and by sometimes you may mean every day, and the first thing you do is you grab your phone. Before you get out of bed, you grab your phone, you look at your phone, and you want to understand what's going on in the world today. What's the current state of affairs in the world? And really point and understand, do I need to roll up the covers and get under bed for another hour because the world's just so utterly wretched? Or can I jump out of bed and start my day? Is the mood of the news overall super positive, or is it really like kind of depressing and I need some more under my covers time because I just can't bear it? And you get all those headlines, all those push notifications. You just want to get to the point. What is the mood of the news? So that's the app that we're going to build together, a mood of the news app that's going to give us that in a quick point. What is the mood of the news? And we're going to build it as a WhatsApp application. So the way it'll work is that a user will send a message via WhatsApp to the application with a topic of the news they want to understand the general mood of. That topic will be searched across the internet for all the news articles on that topic. It'll be sent to IBM Watson's natural language analyzer and then sent through the Vonage messages API, which, as Kevin mentioned in the first talk, is an amazing API which lets you really send messages through multi-channel communications, whether Facebook, Viber, WhatsApp, etc., with just a JSON object. That's pretty cool. It abstracts all that logic for you. So we're going to use the messages API to send it back to the user via WhatsApp, and we're going to do this all as a Ruby on Rails application because I love Ruby and I love Rails, so why not? So let's actually start building it together. Well, as I mentioned, we're going to use 3 APIs. One is the News API, which is has a free access tier, has a Ruby SDK, so it's easy to incorporate and utilize, and it's got some pretty good documentation. We're going to use the IBM Watson Natural Language Analyzer API, and we're going to use the Vonage Messages API. And as you notice, the bullet points for why I chose all these 3 are exactly the same, because these 3 are really important to me as a developer. I want to find an SDK. I want to find ability to play and experiment with the API without having to commit financially to it at that point yet, and I want to have good documentation. So as a Rails application, our first point of entry into it will be our gem file. And our gem file, we're going to define a few of our dependencies. We're going to define our Nexmo Rails dependency. So the Nexmo Rails gem is a gem that we built, which essentially wraps the Nexmo Ruby SDK in a Rails initializer gem. So all you have to do is install this gem and then provide it with API key and API secret, and it does for you to instantiate a Nexmo client globally available in your app. We're going to use the News API gem from the News API, the IBM Watson gem, a couple emoji gems because we want to send an emoji back, and we're also going to Rails gem to safely manage our environment variables in a .env. After we have our gem file, we are going to define 2 routes. This application will have no views. It only has 2 post routes. Both of them are webhooks. If you haven't ever used a webhook before, it's a great opportunity to take a second now to mention what they are. So classically, if you're working with an API without webhooks, you would have to go and actually, it's like sort of like, let's say you want to get an update from your friend and you're curious if something happened. You keep on calling your friend. You say, "Hey, buddy, did this happen? Hey, buddy, did this happen? Hey, buddy, this happened. Hey, buddy, did this happen?" You're calling over and over and over again, asking for an update. A webhook actually flips it and reverses the paradigm and has your friend call you and say, "Hey, this happened." You don't have to be the one engaging and calling all the time. You can let them call you and do the work. So that's a webhook. And our webhook will have 2 routes: an inbound where the message will come into, and a status route which will give us the status updates through WhatsApp. You get status like the message was read, the message was received, etc. After that, we need to define our environment variables and our .env. These are just places where we put our API key and API URL, along with our Nexmo provisioned WhatsApp phone number, which can be obtained through the Nexmo dashboard, and our Nexmo application ID, again, provisioned through the Nexmo dashboard. Once we've done that, the bulk of our logic will lie in our controller. So we've created a controller called news controller, and we need to define a couple actions which will correspond to those routes. One action will be our inbound method, and the other one will be our status method. Our inbound method is where most of the where the action will begin, where the actual logic will happen, and our status method is where the status updates come. We're not actually going to do anything with them, but what we are going to do is just put them out into the console so we can see them as they're happening. And we also return back a 204 HTTP status code to the API, no content, which is essentially saying to your friend, using that friend example, yes, thank you for calling me. I got the update. I'm so glad you called me. If you don't do that, your friend, i.e. the webhook, might want to keep on and ask for that update. So let's define our inbound logic. So our inbound action, which corresponds to the inbound route we created in the routes, is going to do a couple things. One, it's going to assign the data that comes in from WhatsApp to variables that we can use. And the second is it's going to get the headlines and it's going to process them for the natural language processing. And this two variables we want to create is a topic and the number of the recipient, because message back to them. If we don't have their number, we can't send a message back to them. And so the topic comes from the parameters message content text, and the recipient number likewise comes from the incoming parameters from numbers from number. If you're building this, by the way, a production app, you might want to do some work around verifying data coming in, not as data is exact. But since we're doing this as a proof of concept, to help us learn what the mood of the news is, we're going to assume that we're sending the data that we are going to send specifically that we want. And again, we bring a new 204 HTTP status code of no content. We also have invoked a method here called analyze headlines, which we need to build, which will actually do the work of analyzing the headlines. And it takes in two parameters: the topic, again from those variables, topic, and the recipient number. So then we have that. Let's build that method that we have aforementioned method. So the analyze headlines method is going to do the work of actually taking in all those headlines the news API scoured across the web for, and it's going to give us back the all the data around natural language analysis and sentiment on those headlines. To do that, we instantiate an instance of the IBM Watson natural language SDK, and it's a long class name, as you can see, IBM Watson, and then it's namespace natural language understanding v1. It takes in its own IBM API key, and it also takes in its API URL. The API key, we're getting all this data, as we mentioned, from our environment variables, which we had already instantiated in our .env file, so we don't need to actually worry about putting them in a publicly accessible file, which is also, by the way, a good moment to mention. You should never commit your environment variables to version control. You should not let people see your API key in secret. So this is a nice way to put them and use them in our controller without actually having to write them explicitly in the controller. The IBM Watson NLU API also takes a version. This version must have been pivotal in the history of IBM, because it is locked at 2018 November 16th, but I don't know what happened there. We can find out another time, but it takes that version date, and then also the API URL, which we're using the London endpoint for in this instance, so we pass that as well and as an argument. So once we have done that, and of course the version, which we're going to reference here, 2018 November 16th. So once we've done that, and we now have a client instance of the IBM Watson SDK, we can then run the instance from it called analyze, aptly called analyze, tells us what it is. We're going to assign the data that we get back from that to a variable called response. The analyze method takes a couple of its own parameters, one of them being text. And you see text is invoking another method we need to create called get news headlines, which takes in the parameter of topic, which is the WhatsApp message, whatever that topic may be. And then we also give it an object which has its own host of different objects of all the areas that we want analyzed. So we want entities. And if you remember back to the very beginning when we had that whole sheet of sort of data from that sentence around last night I had dinner with someone and all those different topic areas. So what we're essentially saying as we construct this is we want all that data. We could, if we only wanted some of this data, we don't have to specify all of it. But in this case, why not get the entire kitchen sink, right? Let's get everything. So I want the entities, I want the keywords, I want the sentiment, I want relations, I want the categories, I want the semantic roles, and of course I also want the emotion. And what's pretty cool about the emotion, if I'm remembering correctly, is you can actually specify if you want the emotional analysis on the entire, in this case we do, or you can say I only want the emotional analysis on this specific string or in this specific area of the document, which is pretty cool too, because you can hide and really just go down and say, yes, I'm sending you all this data, you know, and it's a book data, but just give me the emotional analysis on one specific thing. And so in this case, we want it on all, and we want the data, and we put out the data. And so that's how we get the data, which then calls that method we now need to create called get news headlines. This method essentially invokes the instance variable called get everything from the news API SDK. We pass into it the topic as the Q, i.e. the query. We say from today, we want the news from, because we wanted the today, and we want to sort it by popularity. Now, the reason why I sort by popularity is because if I'm interested in the mood of the news, what mood of the news, not necessarily the amount of information on a subject, but the amount of eyeballs that have looked at that information. The more people piece of news, one to say helps shape the sort of discourse of the culture around that news. So I want to know the popularity of the news, and it comes back in as an array. The analyzer needs it as a string, so we just basically take the array and pass it into a string, and we return the string called headline string, which is what is used in the actual analysis method we created earlier. Once we have all of that, we then have a very long method here called send WhatsApp message. This is what is using the messages API. So somebody asked earlier in Kevin's talk, can you use the messages API with any language? Absolutely. These are REST APIs. Any language that can speak to an API can make calls to that API. SDKs right now, our Node SDK supports the message API with its own built-in methods. Other than that, you need to actually build out the HTTP call yourself. So here we're essentially just using the HTTP, your built-in HTTP classes in Ruby to build out the method. It takes in a body, which says the from, which would be you with your WhatsApp number, the to being the person you want to send it to, the message, and you pass in here I'm using a here doc to pass in a multi-line string message. And also, if you notice, the from and the to has a type parameter, which is where you say, I want to send this message to WhatsApp or I want to send it to Facebook. And all you need to do is change from WhatsApp to Facebook, and it's a different message. That's pretty cool. I think so. So that is how you would access the API without SDK support, which is building out in whatever language you're using, building out in that native language's capabilities, HTTP calls to the API. Lastly, with a JSON Web Token, a JWT. The API the Ruby SDK does have support to build JWTs for you, which is great because there's a lot of like complexity around JWT, so it's good we abstract that for you, and you just essentially have to call the dot generate on the JWT class in the Nexmo Ruby SDK and passing in your claims, and the claims are just essentially your application ID and the private key that you have from your developer dashboard from Nexmo, and it generates for you a JWT token that can be used to authenticate yourself to the API. So once we've done all of that, we are ready to give it a go. So let's actually do that. So the way we're going to give it a go is we're going to ask our application around the mood of the news on the topic of programming, because we're talking about development. So let's talk about programming. So if we pass in programming, we very interestingly get back some fascinating data. We see that the overall sentiment on programming is negative. So the sentiment is negative with an emotional scoring of 55% of joy and 46% of anger. Well, that is absolutely confusing. What does it mean to say that the sentiment is negative and the emotion is kind of split, not exactly, but roughly split between two extremes in a polarity of joy and anger, 55% of joy and 46% of anger? We have to ask and answer that question, because asking and answering that question will actually have gained a lot of insight into the state of natural language analysis today and where it is at. So let's actually examine the data. So the first thing to examine the data is to look at what were the headlines that actually came to us from the new API. remember, we should never assume the data is what we think the data is. So in this case, the headlines we sent in, I'm going to read all of them to you. It's not necessary, but a cursory scan tells us that there's a lot of different topics here, from IBM and Microsoft seeing a medley of support for Google against Oracle in a copyright lawsuit case. And there's some headlines here around the 49ers, which is an American football team, and something with them. And then there's something here around Stars TV and John Wick. And there's something around iOS update to the public beta 2 and version 13.3.1. and around college humor. And also one headline that's not in English. So if we break it down, we have 18 headlines in our sample. 7 of them are actually related to the topic that we were most interested in, which means that 38.8% of our sample directly related to the topic that we cared about. So the first thing is, examine your data is not usually sometimes what you think it is going to be. So that the 38.8% of our data is what we think. Nonetheless, in that 38.8%, we see that we have this contradictory sort of dichotomy between negative sentiment and then a split in emotionality between joy and anger. Let's take a look at the analysis itself. So as we mentioned, it was an overall negative score of 62% negative, and the emotional results as it came back from the API itself, 55% joy and 46% anger. How is that possible? Well, the first thing to take note of is that sentiment and emotion are not the same natural language analysis. They're two discrete topic areas. They're connected, they're intertwined, but they're not exactly the same. So what is them? So if you remember, going to that sentence around last night I had dinner with someone, it was delicious, there were different areas, there were concepts, topics, keywords that were identified primary in that sentence, and that was a relatively straightforward sentence. In our long string of news headlines, these were the concepts, phrases that were identified. Board of directors, 90%, Richard Sherman, 87%, chairman, 80%, and API at 83%. So what this tells us is that the API was able to understand the topic that was being sent to it in this long string of headlines had to do with, yes, 38.8% of it had to do with, but it was around the business of programming. It was around litigation and lawsuits and corporate battles and different challenges in the corporate logistics of the world of software development. And unless you're a lawyer, and maybe even if you are a lawyer, those topics can elicit some negative sentimentality. They usually, when you think of lawsuits typically evoke negative sentiment, right? They're usually not happy. Maybe they're happy at the final judgment and the person who brought the lawsuit wins a big claim, but typically the whole process is negative. It's a negative sentiment. So yes, the topic was programming, but within programming, it was in an area that evoked negative sentimentality. And yet the emotional scoring was split between joy and anger. When something is split between joy and anger, when there's split two polarities of joy and anger, so almost exactly evenly, there's a lot. And one thing we might be able to say is that when someone is writing something which equally evokes joy and anger, what they are probably attempting to do is be neutral. Because to be neutral is to equally irritate people on both sides of the aisle. And so what you see is a general zeitgeist, a general overall attitude of a negative news, right, of lawsuits. But within the actual words, the way they were constructed by the journalists in those topic headlines were constructed in an effort to be neutral. Interesting. So where does that leave us? Well, it leaves us all the way back to that Turing quote, where we would see a world in 1999 where machines and thinking would not be in dissonance with each other. They would be in consonance, and they would, when you understand and juxtapose the two to one with the other, you would not find them as something utterly contradictory. The question to ask ourselves is, have we reached through the language, which is a great lens to understand if something can think. Have we reached where machines can think through natural language analysis? Do they understand the ambiguities, the complexities, the contradictions of human language? Well, I'm curious what you think. I would love during the break to hear your thoughts on what you think, whether machines are thinking. Thank you so much for taking this time to go on this journey of linguistics and natural language analysis, and a little bit of Ruby thrown in as well. I want to leave you with a couple of resources, namely 2 academic works. One is a book and one is an article. The book is an excellent introduction to the way in which linguistics, the way in which language shapes the way in which we look differently at the world through different languages. And the other one is an article from the University of Chicago, which discusses in depth this concept of polarity, which is utterly fascinating. And then I give you 3 API references for the APIs that we used. Finally, the actual GitHub app. This app is available full source code at that link, github.com/nexmo/mood of the news. The code is there. You can deploy it. You can play with it. You can make it what you would like. Thank you so much.
Thank you, Ben. Thank you, Ben. That was amazing. That was amazing. We have a few questions for you, as you would expect. One of them is, how would a third-party transcription API score a phone call recording, like a voice recording? How would you use that to transcribe voice?
It's a great question. So I've done a lot of experimentation with that myself, just out of utter curiosity, of actually recording different conversations, my own conversations with permission, nothing nefarious there. Recording different conversations and then having them converted to text, and then sending that to, and seeing 2 questions there, right? What is the quality of the text that's converted, and then how is that text, if it was a high quality, i.e. meaning that it accurately converted the words I said into text, then that would be like any other text that one would be able to send to a natural language analyzer. The really pivots how well the speech to text API understands what you said. And there's a whole, that's a whole thing out of the scope of this conversation, but in itself is another fascinating area.
That sounds like the next talk you could work on. Next talk you could work on. I thought that was good. I thought that was good. If you had to say which one would work better, which one had better quality, could you answer that question?
Better quality on which area? The analysis or the text to speech?
On the analysis.
Speech
let's stick with the analysis. With the analysis for now.
Yeah. So when I first put together this presentation, I used big popular ones. The 3 big popular ones, and I'm not going to answer that question, by the way, so I'm going to answer it by not answering it. The 3 big popular ones were IBM, Google, and what was the last one? Oh my God, Azure. And so I went through the 3 big popular, used them and played around with the data, and with simple sentences, pretty obviously each API has its own ways of using it, right? Like, you know, that Alex sort of like has its own sort of like world and language. So each one of them kind of has different for what it calls different things. But the data that came back was roughly, and so once I figured that and saw that it was roughly similar, I just, for the sake of this presentation, down to more narrow scope, I just ended up settling with one, and using that one basically gave me roughly the same amount of information, and it's good information.
Okay, that's good to know. That's good to know that they're fairly similar, and you're not locked into using one that kind
of. The
one
question that I would add, the one element I would add is to make sure if you're, all of them support English, UK, US, right? So they all do that. The question is, like, if you're sending in languages other than English, either UK or US, or I guess Canadian as well, that's essentially American. But if you're, no offense to my Canadian friends, English, UK, or US, something other than those 2, check those APIs and their language support to make sure that the language you want to analyze is actually covered.
Well, that's a really good point. That's a really good point. Are there any more questions for Ben? This is a good time because we're not going to take a break straight after Ben. After Ben, we're going to have another speaker. And if you don't have questions for Ben right now, you can find Ben in the chat. You can find Ben at the tables in about 40 minutes or so, 45 minutes or so, something like that. Okay, So if it doesn't look like there's any more questions for Ben, please reach out to Ben if you've got questions.